Starting and we are live. Okay, so we're going to look at limits that involve radicals. And the one skill that you need to have if you're working with limits that involve radicals is knowing what the conjugate is and yeah, basically just knowing what the conjugate is and how to use it. So I'm hoping that you know what the conjugate is and how to use it. We're going to go through just one quick example of using our technique to find the limit of the difference equation for y equals the square root of x at a particular point. And then we're just going to look at one example where we rationalize the denominator. Okay, so here comes the problem. Find the slope of the tangent to y equals the square root of x at the point x equals 5. And of course, if x equals 5, y is equal to the square root of 5. So if we want to find the slope of the tangent at that point, we use our difference equation, which always starts out like this, since it's a tangent anyway. The slope, m, is equal to the limit as h approaches 0 of, wow, look at me. I'm going to use the meter stick today. Just, I'm very patient. 5 plus h. Subtract square root of 5 all over h. Are we good so far? Everybody's good? Thumbs up? All right. Now, if we plug in a 0 for h, it kind of looks okay. Oh, you know what? Except for this. I'm surprised you guys didn't say. You forgot your subtracting sign, but that's okay. So 5 plus h minus square root of 5 plus h minus square root of 5 all over h. That's my difference quotient. If I plug in a 0 for h, the bottom turns into a 0, and we have that terrifying situation of not knowing what number that actually is. But fortunately, we know about conjugates. We can actually fix this. Hey, kids, let's multiply by the conjugate. Going to use my ruler again. It's my New Year's resolution. It's probably going to break down partway through this, but that's okay. Square root of 5 plus h plus the square root of 5. And I can't just willy-nilly multiply a function by something. I have to multiply it by 1. So I have cleverly multiplied it by 1 while multiplying the top by the conjugate. Okay. Next step. Make sure you put your limit in every time. And I say that because I always forget to do that. Okay, square root of 5 plus h times the square root of 5 plus h is 5 plus h. And then negative root 5 times positive root 5 is minus 5. Look at that. It's going to, this is going to go away. The 5 is going to go away. And the bottom is h times square root of 5 plus h plus square root of 5. All right, good. It's looking good already. And did you notice that I put my limit in and I used a ruler to make that underlining thing there? Okay, not going to forget the limit as h approaches 0, 5 plus h minus 5. And I'm going to simplify the top. That simplifies to an h. And I'm not going to do anything to the bottom because I can see I've got this h in there. It's going to disappear for me, which is exactly what I want it to do. Okay. Now, what I'm going to do here is I'm going to cancel those out, top and bottom. So I have a 1 on top. Nobody make the mistake of thinking that that cancels out and turns into a 0. That's just deadly. Okay, I'm going to erase this line. Not that it no longer exists. It's just that it's in the way and inconvenient. And so when you're doing these, you know, this is kind of some extra steps just to show you where things are coming from. And this is 1 over the square root of 5 plus h plus the square root of 5. Now I'm going to see, can I put in a 0 for h and everything is still okay? The answer is, well, yes, I can. Okay, so this is 1 over the square root of 5 plus 0, which is the square root of 5, plus the square root of 5. Not the square root of 2, but the square root of 5. Which then becomes 1 over 2 square roots of 5. I'm always kind of happy when you get to that stage. Technically, you need to rationalize the denominator, which means take the square roots out just so that everything looks beautiful. And so we'll do that for the sake of meeting the standard here. And this becomes the square root of 5 over 2 times square root of 5 squared, which is root 5 over 10. And so hopefully, if I were to use some graphing technology software and find the tangent at 5 root 5, it would have the slope of root 5 over 10, which is, I don't know, it's about 0.23, something like that, which makes sense because this is that square root curve. And it hasn't translated, so it looks something like that. 5 is about here. I'm definitely expecting a positive slope. So there we go. That's what it looks like in not real life. Okay. Are there any questions about that? Because that's the main example. Signal your approval by not saying.
What if your function with a radical isn't as simple? Like, what if it's, square root of 5x plus 2 plus 1 or something,
Yes, and that's a good question. So we actually get a little bit more abstract with it, but you will actually find that when you're multiplying by the conjugate, most of those things fall out quite nicely. So this will work with more complex functions for sure. That's a good question. All right. Any other questions? No other questions. Okay. One last example. This one's a little less germane. It's more thought-provoking than it is related to calculus and finding the difference quotient, but it does relate to limits. Okay, so question is, does the limit as x approaches 0 from above of this weird function, x over the square root of 2x, I'll keep my x's consistent here. So does the limit as x approaches 0 from the above of this function actually exist? Okay. So let's give it the quick check here. Limit as x approaches 0 from above of x over square root of 2x. Notice I didn't use my meter stick there. Sticking it to the man. If I substitute 0 into this, it blows up on me. And so this isn't going to work. But we might be able to do some fancy stuff. We might be able to rationalize the denominator. And you'll see that we might be able to cancel out some x's and make some magic happen. Okay. So let's look at this. Let's change the form a little bit. See if we can fix it up. X over the square root of 2x. So I'm just going to rationalize the denominator. Be rational, denominator. Root 2x over 2x, multiply it by the square root of 2x over the square root of 2x. And the denominator is going to become less problematic. Okay. The numerator, however, turns into something that only a mother could love. Okay, so this is the square root of 2 times 2, 4, x squared. And this is going to simplify a little bit further. Limit as x approaches 0 from above of x times the square root of 2x. And I can pull this out. Square root of 4 is 2. Square root of x squared. Okay. So this is where we're at so far, and it just looks beautifully tempting. Let's just take the square root of x squared, and so let's just leave that as an x. And sometimes it's just not that simple. This function, the act of squaring the value of x and then taking the square root, works fine if x is positive. But when x is negative, this set of functions will actually make x positive. And so we have to be careful about what domain we're in, if we're greater than or less than 0. And so normally, we would, in order to be careful about this, we would say, this is equal to the limit of x times the square root of 2x over 2 times the absolute value of x, okay? Because this square rooting this thing squared actually turns it into the absolute value of x. And so that would be the normal way we worry about that. Fortunately, though, we're approaching 0 from above. And so x is positive. We've actually specified what domain we're in by approaching it from above. So we can happily erase those absolute value brackets. And then we don't have to treat this thing with complicated cases. So there we go. Things are simpler. Life is back to normal. I'm going to cancel those x's. And I have this nice limit as x approaches 0 from above of square root of 2x over 2. And if I substitute 0 into this, everything is beautiful. The top is 0 and the bottom is 2. And so that limit is actually just 0. Okay, so that's that. End of the broadcast. Are there any? This second example, by the way, is a little more academic. It's a little less sort of skill-based, but it is just a nice way to think about limits. And
will these tricky sorts of things come up a lot in this course?
And so
I never would have thought to do that. I would have just haphazardly put x right back in without thinking about the absolute value.
So are you talking about, like, maybe you do this?
Yeah, I was with you up to there, but then I'm like, oh, he's gotten really tricky now.
Yeah.
So if you were looking for that, you definitely would have tripped me up.
Right. And you know what? If you'd made it to that point, I think basically we could have said that you're in great shape, basically. It's good. You can definitely see how this results in the absolute value of x, though.
Yeah, yeah.
Yeah, you're just saying I wouldn't spontaneously just rewrite that as the absolute value of x.
I see. When you multiply square root of 2x by square root of 2x, on my note, I just put 2x as the bottom. I didn't go through the square root of 4x squared part.
Oh, okay. Yeah. And I was putting in some extra steps, so I can definitely see what you're saying here. Like, there's all these extra steps, and you get to there, and you would just go straight to the square root of 4x.
No, I would just go to 2x.
Yeah, that's right. You just go straight to 2x.
I would skip right past that.
Yeah. Yeah. And so my answer is I wouldn't be horribly concerned about just missing that fact because it doesn't actually randomly pop up that much. But as long as you understand that that was the absolute value of x, I think that's actually pretty good.
Okay. You got to be careful with these things then.
Yeah. And I think that's a really good question to ask at this point, actually, is like, would I be expected to spontaneously know that that's the absolute value of x? And would I get 0 out of 5 if I forget to put the absolute value of x? Yeah. The answer is that really, it might come up, but probably not.
Yeah. Okay.
Does that make you feel like that's a great question? Does that make you feel kind of comfortable about that?
Yeah. It's an interesting problem to have to check for that.
Yes. And I'd have to check the curriculum, but when we're talking about absolute value, we don't actually do that much in the Ontario curriculum related to absolute value, and I thought it was good to just throw it in there.
Okay.
All right. So that's it. The important skill that you need to know about are using conjugates. When you're using them with the difference quotient, basically the conjugate's always going to be the same. It's going to be the square root of whatever it is plus the square root of whatever it is. And it usually simplifies down. The reason you're using it is to cancel that h in the top and bottom. So you need to look and see that that h is going to cancel out. Griffin, you were saying when the function gets complicated, sometimes you have to factor the h out of the numerator so that you can cancel it top and bottom. But basically that will look after doing these limits with radicals and doing the difference quotient with like square root functions and functions involving radicals. All right.